Okay, today we'll be going over the review for the test on Thursday. This is primarily for 7th period because I'm not going to be there to do it in class. I've got a doctor's appointment. So, I'm going to go ahead and go through each of these. Number 1, we are finding the slope passed through the points 3, 2, and 8, 12. So our 2 points, 3, 2, and 8, 12. So this is simply rate of change slope, which is delta y over delta x, which is y2 minus y1 over x2 minus x1, change in y over change in x. So in this case, we have 12 minus 2 over 8 minus 3, and we'd have 10 over 5, which is 2. So our slope for the first one, number 1, would be 2. Number 2, 4, 8, and 4, 3. So our 2 points, this is number 2, 4, 8, and 4, 3. Alright, so same thing, delta y over delta x, change in y over change in x, so 3 minus 8, and 4 minus 4. So our numerator is negative 5, our denominator is 0, and you can't divide by 0, so this slope would be undefined. This is no real slope here, we have an undefined slope. The next one, negative 5, negative 2, and 10, negative 7. And 10, negative 7. So same thing, delta y over delta x equals, so negative 7 minus negative 2, so that would be plus 2. And then 10 minus negative 5, so that would be 10 plus 5. So I would have negative 5 over 15. And then you definitely want to reduce this, which is 1 over 3, negative 1 over 3. So my slope for the next ones, and I think this is problem 3, is negative 1 over 3. Alright, and then number 4, 2, 7, and 8, 7. Alright, same thing, delta y over delta x. So I have 7 minus 7 over 8 minus 2. So I have 0 over 6, which is just 0. 0 in the numerator, the slope is 0. So number 4, the slope is 0. Alright, number 5, find the average rate of change from when t equals 9 and t equals 10. So this is pretty much the exact same thing as the last one. You just have to find the ordered pairs on the graph. So if we look here, when t is 9, then the y-coordinate is 60. That's our first ordered pair. And then the next one, when t is 10, the y-coordinate is 30. So to find the average rate of change, we're looking for slope. So we do y2 minus y1, 30 minus 60, over x2 minus x1, 10 minus 9. So that leaves us with negative 30 over 1, or just negative 30. Either one of these would be fine. Alright, good. Alright, so now we are looking at number 6. We want to graph y equals negative 3x plus 4. Alright, so our equation, y is equal to negative 3x plus 4. Graph this by using the slope and the y-intercept. So the slope negative 3 over 1, because we need a rise and a run, and the y-intercept is 0, 4. So we'll graph our y-intercept, which is 0, 4, that will be right here. And then our slope, which is negative 3 over 1, which means this should slant downwards, so down 3, so 1, 2, 3, and over 1. Or we could also go 1, 2, 3 up and over 1, as long as we get to the right place. I will connect these to form my line, like this. And that would be my line right there. That's number 6, I believe. Number 7, 2x minus 3y equals 6. 7, 2x minus 3y equals 6. So this one requires us to actually put it into slope-intercept form, which means subtracting the x and then dividing by the coefficient. So we do minus 2x to both sides, which will leave us with 3y equals negative 2x plus 6. We'll divide by 3. Sorry, that's a negative 3 because of this. It's a negative 3. Divide by negative 3. And that will leave us with y is equal to negative over negative is positive 2/3 x minus 2. And then we'll put this into slope-intercept. This is in slope-intercept form, so we can find the slope, we can find the y-intercept. The slope is 2 over 3. The y-intercept is 0, negative 2. Slope comes from this number, the coefficient on the x. The y-intercept comes from the constant. So 0, negative 2 is right here. And then our slope up 2 over 3, since it's positive. Or I can go down 2 and over 3 this way. Connect to form my line, draw my arrows, and I have my line for number 7. Alright, number 8, x plus y equals 0. Number 8, x plus y equals 0. Very similar to the previous problem, except there's no coefficient on the y, but we still got to get rid of the x, so minus x. 0 minus x is just negative x, so we have y is equal to negative x. Slope of this line, negative 1 over 1, because the coefficient of x is 1, negative 1. The y-intercept of this line, since there's no value, there's no constant value, is 0, 0. So we'll graph 0, 0 right here. And then our line needs to point down like this, so we go down 1 and over 1, or we could go up 1 and over 1. Either way, it's going to give us our line. Like this. Okay, let's see, number 9. Oops, I didn't look at it. Number 9 is y equals 4. This one's real easy. This is just a horizontal line that goes through 4 on the y-axis. So it goes through 4 on the y-axis. Everything on this line has a y-coordinate of 4. Put arrows on it to imply that it goes on forever. And there we go, y is equal to 4. Number 10, x is equal to negative 5. This is very similar to the previous problem, except this will go through the x-axis at -5, and it is a vertical line. It's like this, and every ordered pair on this will have an x-coordinate of -5. Alright, number 11, solved by graphing, and we have a system, x plus y equals -1, x minus y equals 3. So x plus y equals -1, x minus y equals 3. Let me make sure I've got that correct. X plus y equals -1, x minus y equals 3. Alright, so I do need these both to be into slope-intercept form. So the first one, I can just subtract the x. So to put the first one in slope-intercept form, y is equal to -x minus 1. Put the second one in slope-intercept form, I will need to subtract the x, and then I will also need to divide by -1. So it'd be -y equals -x plus 3, and then I'd need to divide by -1, so y is equal to x minus 3. So here's my first equation, here's my second equation. The slope of my first equation, -1/1, the y-intercept, 0, -1. For my second equation, the slope is 1/1, the y-intercept is 0, -3. Okay, so let's graph the first line in blue, and then I'll do the second line in red. So the first line in blue, I will have -1 as the y-intercept, and then it's a negative slope, so down 1/1, down 1/1. Remember, you want to graph pretty much as many points as you can to make sure that you find where these two lines intersect, okay? So there's the first one. Let me graph the second line in red. So I got 0, -3. It's a positive slope of 1. So up 1/1. And it looks like I already found the solution here. I only had to graph one point. I found the solution because the solution is where these two lines intersect each other. And that solution is the ordered pair 1, -2. It's the only ordered pair that works for both equations. Alright, you plug it into both equations, it makes sense. 1 minus 2 is -1. 1 minus -2 is 1 plus 2, which is 3. So it works for both ordered pairs. Alright, let's look at number 12. Y equals -3, x plus y equals 2. So y equals -3, x plus y equals 2. The first one is pretty straightforward. -3, it's a horizontal line that goes through -3 on the y-axis. Put arrows on it to imply that it goes on forever in both directions. X plus y equals 2. We do need to subtract x to get this on the other side, so it becomes y equals -x plus 2. So the slope of this one is -1/1, and the y-intercept is 0, 2. So I'll graph the y-intercept, which is 0, 2. And then I want to go down 1/1 because this negative slope line should point down. And I'm going to keep going until I hit this red line because that is where my solution is. And I do hit it eventually. hit it at the ordered pair 5, -3. And that will be the only ordered pair that works for both equations. And you can see y equals -3, of course, it works for the first one. And then for the second one, 5 plus -3 is 2. It definitely works for the second one. So this would work for both the first and the second equations. So that's number 12. Number 13, 2x plus y equals 7, y equals x minus 2. 2x plus y equals 7. Y equals x minus 2. Second equation is already in slope-intercept form, so I will just graph that one. Slope is 1 over 1. The y-intercept is 0, -2. So 0, -2 is right here. And then it's positive slope, so up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Could also go down 1 over 1, down 1 over 1, down 1 over 1. That should hopefully be enough points to find the intersection, and it might be a few too many, but we don't know. So, whoops. Okay, that didn't come out too bad. Okay, let me draw the arrows on these to imply that they go on forever. Okay, the second line, 2x plus y equals 7. All right, to get this in slope-intercept form, I just need to subtract the 2x. So we have y is equal to -2x plus 7. Slope of this is -2 over 1. Y-intercept is 0, 7. So 0, 7 is right here. The slope, downward sloping, down 2 over 1, down 2 over 1, down 2 over 1, and there I am. I hit the second line there. I hit the red line. And once I hit the red line, that is going to be my solution, which is 3, 1. 3, 1. You plug that into both equations, it will make sense. So 2 times 3 is 6, plus 1 is 7. True. 1 is equal to 3 minus 2. That is also true. So this is number, what number is this? This is number 13. All right. Number 14, solve by elimination. 2x minus y equals 7. So my first equation, 2x y equals 7, and this is 14. And then my second equation, 3x minus 2y equals 10. Okay, so the key to this is making sure something eliminates. So it's looking pretty clear that I'm going to have to multiply the first equation by -2. So the y's will eliminate. I'll have +2 and -2y. So that becomes -4x plus 2y equals -14. This one stays the same. 3x minus 2y equals 10. And I'm going to add these together to get a new equation that only has one variable. So that would be -x, cancel, cancel, equals -4, which means x is equal to 4. Because you divide both sides by -1, you get x is equal to 4. So the first part of the solution is 4. To find the y, I'm going to plug in the x into one of these. I'm going to do the first one. Why not? 2 times 4 minus y equals 7. 8 minus y equals 7. Subtract 8 on both sides. Negative y equals -1, or y is equal to 1. So 4, 1 should be my solution. I do want to check it. 8 minus 1 is 7. True. 12 12 minus 2 is 10, that is also true. So this 4, 1 is my solution to number 14. (15) 5x plus 4y equals 6. Alright, and then my second equation, 2x plus 3y equals 1. Alright, both of these equations are going to need to be changed for this to work. So I'm going to I'm going to get rid of the x's, and I can do that by turning these both into 10 and negative 10. So I'll multiply the first equation by negative 2, and I'll multiply the second equation by 5. First equation becomes negative 10x minus 8y equals negative 12. The second equation becomes 10x plus 15y equals 5. Add these two equations together, the x's cancel. I have 7y is equal to negative 7. Divide by 7, y is equal to negative 1. So, the y-coordinate of my solution is negative 1. I'm going to put this back into the first equation to figure out what the x-coordinate is. So 5x plus 4 times negative 1 is equal to 6. So 5x minus 4 equals 6. Add 4. 5x is equal to 10. Divide by 5. X is equal to 2. So my solution where these two cross is 2, negative 1. And you can check that 5 times 2. So we got 10 minus 4 is 6, correct. 4 minus 3 is 1, also correct. And this was 15, I think. Yes, 15. So it's problem number 15. Okay, number 16, 5x minus 2y equals negative 19. And then the second equation, uh, 2x plus 3y equals 0. Alright, so I think in this one I will get rid of the y's since they already have opposite signs. So I'll multiply the first equation by 3, and I'll multiply the second equation by 2 to make the coefficient on the y's both equal to 6 and negative 6. So I got 15x minus 6y equals, oh god, 50 something. Let's see. 19 times 3, I'm pretty sure that's 57, but I'm not going to bank on it. And it is 57. Okay, so negative 57. And then my second equation becomes 4x plus 6y equals 0. Alright, I'm going to add these together. So I get 19x, these y's cancel, equals negative 57. Pretty sure I know how many times 19 goes into 57 because I just did it. It's negative 3. So the x-coordinate is negative 3. I'm going to put this back into one of these equations. I think I'm going to go with the second one. The second one looks a little bit easier. So I'm going to do 2 times negative 3 plus 3y equals 0. Negative 6 plus 3y equals 0. Add 6 to both sides. 3y is equal to 6. Divide by 3, y is equal to 2. So the ordered pair where these cross is negative 3, 2. And I'll plug these in to double check. 5 times negative 3 is negative 15, minus 4 is negative 19. And then 2 times negative 3 is negative 6, plus 6 is 0. So I'm good there. Number 16, I'm good. All right. Number 17, solve the system of inequalities. Y is greater than or equal to negative 2x plus 2. Okay, so y is greater than or equal to negative 2x plus 2 is our first equation. And our second equation, y is less than or equal to 3x. Okay, so the only difference between this one and the one we were doing before is this one we have some shading to do. So these are already both in slope-intercept form. The slope of this one, negative 2 over 1. The y-intercept, 0, 2. So I'm going to graph that. 0, 2 is right here. Down 2 and over 1. This is a solid line because of the line underneath the inequality symbol. So I'll draw a solid line. And then for this other one, remember I'm looking for where these shaded areas overlap. The slope of this one is 3 over 1, and the y-intercept is 0, 0, because there's no constant here. So 0, 0 is here. Slope up 3 over 1. Oops, I actually forgot to do the shading on the other one, so I'll do the shading on the other one in just a second. This one's also solid because of the line underneath. And yeah, I totally forgot the shading on both of these lines. So the red one is shaded below because it's less than. So this one is shaded below the red line. And then the blue one, we have, whoops. The blue one we have shaded above because it's greater than. And where these two overlapping regions are, that's our solution. So our solution is in this little quadrant right here, this little space right here. That's all there is to finding our solution. We can pick any ordered pair in this area over here and plug it into our equations, and it will make sense. What number was this? This was number 17. This was number 17. All right, let's go ahead and look at number 18. Y is greater than 3x plus 2. And then our other equation, y is less than or equal to negative 2x plus 1. Y is less than or equal to negative 2x plus 1. All right, we will graph these separately. This first one has a slope of 3 over 1. The y-intercept is 0, 2. So 0, 2 is here, up 3 and over 1. So this will be a dashed line because there's no inequality symbol, there's no equal to symbol on the inequality. Whoopsie. So dashed line. And it's shaded above because it's a greater than symbol, so we'll shade it above. Like so. Alright, the second one, slope negative 2 over 1, the y-intercept 0, comma 1. So 0, comma 1 is here. Slope down 2 and over 1 because it's pointing down. It is a solid line. And it is shaded below because it's a less than symbol. And we can see where the blue and the red overlap. That is our solution area right here. Splits it into 4 quadrants. This one over here is our solution area. All right, number 19. 2x minus y is greater than negative 2. Y is less than negative x plus 1. And y is greater than or equal to negative 4. Got a lot of equations here. Alright, this is pretty much the bad boy of all the problems. Second, I'm going to mark these so I can do them in different colors. Blue, red, and then the last one I will do in green. Gonna have a lot of stuff looking for overlap here. Alright, so the first equation I have to put in slope-intercept form. So I have 2x minus y greater than negative 2. I will subtract the 2x. So negative y greater than negative 2x minus 2. Divide by negative 1. Remember, when you divide by a negative, the sign flips around, so it becomes 2x plus 2. Okay, so my first one, y is equal to 2x plus 2. I don't have room to write down the slope and the y-intercept all over the place, but the slope of this one is 2 over 1, the y-intercept is 2. So I'm going to go to 2, and my slope is 2 over 1, so up 2 over 1. This is a dotted line. Or a dashed line. I think I've been calling it dashed line. It's a dashed line, and it is shaded below. So like so. Okay, second equation. Or inequality, sorry. It's already in slope-intercept form. Y is less than negative x plus 1. Slope is negative 1. Y-intercept is 1. So I'm going to put the y-intercept here at 1. And then I'm going to go down 1 and over 1 because the slope is negative 1. Negative 1 over 1. Alright, this is also a dashed line. And then the shading on this one, this is number 2, it is below because it's a less than symbol, so I'm looking at below, like so. Alright, now the last one, y is greater than or equal to negative 4. This is a horizontal line at negative 4 on the y-axis, and it's solid. So negative 4 Alright, so it's my green line here, and it is shaded above, like so. I'm looking for where the blue, the red, and the green overlap, and I'm going to shade it in so that you can see it. It's a little bit hard to see, but it is. I'm going to shade it in orange. It is this triangle right here where the green, blue, and red. I'm going to need something thicker than that. this triangle here. Right here. Everything inside this triangle will satisfy all three inequalities. Any ordered pair in here will satisfy all three inequalities. That is the solution inside of this triangle right here. Okay, good. All right, that was number 19. Number 20, the sum of two numbers is 52. The difference of the same numbers is 20. Find the numbers. Okay, so the first equation, their sum, and this is number 20, their sum is 52. Their difference is, I forgot, 20. Okay, so their difference is 20. All right, so I want to find the two numbers. Pretty straightforward. This is a elimination problem, and it's already set up for elimination, so I'm just going to add them together. The y's will eliminate. 2x is equal to 72. I'll divide by 2. X is equal to 36. So one of the numbers is 36. If I want to find the other number, I just plug this into one of the equations. I'm going to use the first one. 36 plus y is equal to 52. Subtract 36 on both sides. Y is equal to 16, I think. 52 minus 36 is 16. So the other one is 16. And you can check this quickly. The sum of these, 36 plus 16 is 52. The difference, 36 minus 16, is 20. So number 20, 36 and 16. All right, number 21. At Bob's Burgers, Tim bought 4 burgers and 6 orders of fries and paid $28. Okay, so 4 burgers and 6 fries, $28. So 4b plus 6f equals $28. Okay, great. Second equation. Joe, 6 burgers and 2 fries, $29.40. Okay, so 6 to $29.40. So 6 burgers plus 2 fries equals $29.40. All right, so this is once again a simple elimination problem to find the solution. That's probably something easier than doing that, actually. I was going to multiply both the equations, but I think I can get away with just multiplying the second equation by -3. And that might be easier. The first equation will stay the same. 4b plus 6f equals 28. Second equation will get multiplied by -3, so I get -18b minus 6f is equal to, going to definitely need a calculator for this one, 2940 times -3 is 88.2. And now I can add, sorry, -88.2. That was almost a problem. Should definitely be negative because 2940 times -3 is -88.2. Okay. All right, add these together. -14b, the f's cancel, the fries cancel, and then 28 minus 88.2 is -60.2. Now, we're definitely not going to get whole numbers on this one because we're talking about cost. So we'll divide by -14. So 60.2 divided by 14, we got 4.3 or $4.30. So the cost of each burger is $4.30. Let's go ahead and put this back into one of the equations. The first one actually. 4 times 4.3 plus 6f equals 28. So 4 times 4.3, 17.2 plus 6f equals 28. Subtract 17.2. 6f equals, so 28 minus 17.2 is 10.8. We'll divide by 6. So f is 1.8 or $1.80. So the cost of each burger is $4.30. The cost of each fry is $1.80. And that was number 21. And that is all of them, and I think all of the answers were there, and should have been checking them as I go, but I'm pretty sure I got them all correct. So thanks for joining us here. Study this, be prepared. Thank you.